Welcome to page 2 of your linear equations packet. For this lesson, we're going to be comparing proportional linear equations and the graphs of those equations to non-proportional linear equations and the graphs of those equations. Let's take a look at our first coordinate plane. Let's take a look at our x-axis on the coordinate plane. Make sure you label your diagram with an X. Your X coordinates will control your side-to-side movement on the coordinate plane. We move to the right if the coordinate is positive, and we move to the left if the coordinate is negative. And your vertical axis is the y-axis. If it's a positive y coordinate, we'll move upward. But if it's a negative y coordinate, we'll move downward. Remember, our coordinates are always given in an ordered pair. X will always come first, and it dictates your side-to-side movement, and your y will control your up or down movement on the coordinate plane. Now, keep in mind, as we plot points, we typically start at the origin, which has the x and y coordinate 0, 0, and move from there. Make sure you've labeled your graph with x and y, and you've taken down the notes. Let's begin with a story problem. We have two brothers, Josh and Jordan, in second grade. They are going to save money in their piggy banks over the next few weeks. Take a moment and create a T-table on your paper. X will represent the weeks, and Y will represent the dollar amounts each boy has saved. So our x-axis represents the weeks, and our y-axis represents the dollars saved. So let's say Josh starts out with an empty piggy bank. 0 weeks, $0. After the first week, he saves $2. He plans on putting $2 a week into his piggy bank. After the second week, he adds another $2. He's up to $4. And after the third week, he's actually up to $6. We see a change that occurs. He is going to add $2 each and every week. That is known as our delta y. That explains how our y values are changing. Over on the other side, our delta x, or our change in our x values, you can see that each x value grows by just 1. Now, let's make a list of our ordered pairs and plot those points. Remember, x is first, y is always second. So our first ordered pair is 0, 0. Our second ordered pair is 1, 2. Then 2, 4. And finally, week 3, $6. Please list your ordered pairs on your paper, and let's begin to plot. Our first point is 0, 0. Please darken the point and label it with the ordered pair 0, 0. Then our next point is over 1, up 2. That is 1, 2. Please label that. Then over 2, up 4. And finally, over 3, up 6. And you can see a pattern is evolving. In fact, you could predict probably where the next week is going to go. Remember, we are going up $2 over 1 week. Up 2 over 1, up 2 over 1. So, up 2 over 1, you would predict that for week 4, he would have $8 saved. And the pattern would simply continue. Take a moment, grab a ruler, and connect the points. If you need to pause your video at any time to catch up on the notes, please do so. Now, let's take a look at our rate. We have delta y, change in y, over change in x, y over x. And in this case, we grow by $2 each week, and our delta x over 1 week. So our rate of savings, $2 per 1 week. The equation that we could write for this particular problem would be this: 2 times x, the number of weeks, equals y, the total amount of money. Obviously, this is a proportional relationship. Just by looking at the graph, you can see that we start at 0, 0, and our line is straight. But let's take a look at a non-proportional relationship. Let's say Jordan is going to save money in his empty piggy bank. Create a tea table in the work area. The only problem is, before Jordan can start saving, he owes his sister $2. So, in a sense, he's behind by $2, or in the hole $2. So, for the start amount, he's actually at a $2 deficit, or a loss of 2. But he's going to save a bit more money each week than his brother. He's actually going to add $3 to his piggy bank each and every week. That's our delta y, or our change in y. So, after the first week, and after he pays back his sister, he's up $1. Then he's going to increase by another $3, and after the second week, he has $4 in his piggy bank. And finally, after the third week, he has $7 in his piggy bank. Our delta y, or our change in y, is 3. We are adding 3 each time. But our delta x, please write this down. Once again, we're only growing by 1 for our delta x. Let's take a moment and list our ordered pairs. We have 0, -2, 1, 1, 2, 4, and 3, 7. Remember, when we plot, we should always label our x-axis and our y-axis. And in this case, of course, x represents the number of weeks and y represents the dollar amount. Let's take a moment and plot these points. To begin with, we're not going to start at 0, 0, because remember, Jordan owed his sister $2. Our first point is right here at 0, -2. Our next point is, let's label that 0, -2. Our next point is over 1, up 1. Then over 2, up 4. And finally, over 3 up 7. Take a moment and connect your points. This graph represents Jordan's savings. Now, let's take a look at our rate, delta y over delta x. Remember, we have $3 per every 1 week, which is a rate of 3. We're going to write an equation which looks like this, and we have to keep in mind that Jordan started out at a loss of $2 because he owed his sister $2. So we would represent this particular relationship between x and y like this. $3 times every week x minus the $2 he owed his sister equals y, the total savings. Clearly, this second equation is not proportional. And if you look at the graph, clearly it doesn't start at 0, 0. It is straight, it is linear, but it does not start at the origin. One finishing touch before we leave this page is it's tradition to label each line with the equation. So, for Jordan, let's label the equation represented by this particular line. And for Josh, let's take the equation and label it right below the line. Make sure you have all the notes and make sure you review what's the difference between a proportional relationship, clearly the equation we write, and, of course, when we graph the information, we know it starts at 0, 0, and the line is straight, versus what does a non-proportional equation look like? Well, certainly there's a bit more information in a non-proportional, and we'll explore this in detail. But if you look at a graph for a non-proportional relationship, it's still straight. Of course, it's a linear equation. But the big difference here is the line never passes through the origin. 0, 0. This concludes the lesson for page 2. Please make sure you have all the notes. If not, pause the video, go back and complete your notes for this page.